Hey everyone, my name is Brian Lagunas and I am a senior product owner at Infragistics. I am also a Microsoft MVP. I am a speaker, trainer, and a Pluralsight author. And I'm also well known for owning and maintaining the very popular Prism library. I also post a lot of video training material on my YouTube channel at youtube.com/Brian Lagunas. If you ever want to reach out to me personally and ask a question, feel free to contact me on Twitter at twitter.com/Brian Lagunas. And I also live stream on Twitch. So if you ever want to see me struggling with code, just like everyone else, feel free to follow me on Twitch at twitch.tv/Brian Lagunas. So today I want to talk to you about how we can build composite Xaml applications with Prism. And so you're asking yourself, well, Brian, what is a composite application? Well, historically, when you build applications, we normally build them as like a monolith, right? And a monolith is an application that is kind of made up of one project and everything's in that project. And that has a lot of, issues developing code that way. What we want to do is we want to take these large applications and we want to break them down into smaller, more manageable pieces, but at runtime, have all these small pieces come together as a single whole application. And that gives us a lot of benefits such as testability, extensibility, maintainability, all the abilities that you get. And there's just a ton of great benefits building applications this way. And this really comes from a number of challenges that we face as developers, especially within the enterprise. When I was building enterprise applications for a construction company that had over 60,000 employees, huge company, we had to be very specific about how we built our apps. And these are some of the challenges that I faced personally. This includes okay, you're in enterprise, you're writing apps, you probably have a number of teams. These could be large teams, these could be teams that are maybe spread out across the world in different countries, but they're all trying to work on the same files and the same projects. And if you are in that situation now where you have multiple teams trying to hit the same file, you know that there's a lot of issues with trying to commit those changes or having conflicts and, whose change gets added, or maybe you're working on the same files but different areas, but when you go to check that code in, you have a lot of conflicts. So there's a lot of problems with developing apps that way when you have a lot of large teams. Another thing that you have that normally happens with this is you have a lot of duplicated infrastructure, right? A lot of code that's just duplicated throughout your application. And not necessarily through your application. If you're in an enterprise or in a company that writes multiple applications, you'll have a lot of code that you'll want to share. And sometimes you want to actually share complete portions of functionality like logins. Maybe you have a very nicely designed login flow UI that you want to share with every application. Or maybe you have a shell of your application that you want to standardize on in your entire organization, and you want to inject mini apps into that. Those kinds of things become real challenges in larger enterprises. Also, a consistent project structure. This is another challenge that a lot of companies struggle with. When you write applications, you want to write them in a way that's consistent, okay, across every app. You want to try to write them where they're structured the same, the code flows the same, everything is organized the same, and this gives you a lot of benefits when you do it this way. For one, it's easier to it's easier to maintain those projects, right? So I can jump from project A to project B to project C, and no matter what application I'm working with, I know where to go to find things. I know how this is structured. I know how it works. So there's not a lot of context switching, which can really be problematic. But if there's not a lot of context switching and you can jump from app to app without a lot of overhead, that is a huge benefit to the company. Not only that, it's easier to bring on new employees or new hires, because if you have your applications across the board structured the same way, or at least in a very similar way, new hires can come learn that structure in one application and then immediately feel more comfortable in the next application or in another application, right? So as they jump from app to app, even though they're new, they'll be much more comfortable. Another thing that comes with, developing a number of apps in an enterprise or any company is code quality. You want to make sure your code is easy to maintain, easy to read, and most importantly, easy to test. Testing is extremely important. And a lot of ways that apps are built today, testing isn't really considered. And even if you wanted to test, even if you said, I want to test this, it's possible that the way you're writing your code now will not allow you to test those applications. Even if you wanted to, they're untestable because of the way they're written, okay? Another important aspect of writing these types of applications is your app requirements will change over time for a number of reasons. It could be customer demand and feedback. It could be the direction of the company has changed. But if one thing is true, is change is constant. It's always happening. And your application has to be flexible enough and has to have the ability to be extended without breaking any of the existing functionality that your applications have. You don't want to go add a new feature and then break an old one. We don't want regressions. And so we want to make sure that we structure our applications a certain way. We code and we write our code in a certain way that they're testable, and we can protect ourselves from those types of changes. So if we look at this design I have here, this diagram, this is kind of how apps are developed today. Okay, these are referred to as a monolithic application, just one big application. So imagine we're inside Visual Studio and we have this solution. There's our solution folder. And within that folder, within that solution, we have our main project. And that main project essentially contains all the views and all the code and everything that's required to make this application work, right? We have one main project. Now, I'm not talking about, maybe you have a utility project, or maybe you have some business objects in another project. I mean, no, the functional aspects of this application are all in one big, huge project, normally structured out with different folders, and so this is not how we want to write applications. Okay, we do not want to do this. Instead, we want to move to a more modular approach. Okay, this kind of gets back to the title of this talk where we talk about composite applications. And what this means is, now picture this. We're inside Visual Studio. We have our solution, but now our main project is just merely a shell. It's one view. That's really it. And in this view, we'll have some regions. Okay, and these regions are just going to define where we're going to be hosting views from other modules. We use the term module, and I like to look at as a module as more of a functional area of your app. Okay, so if you think of like Outlook, Microsoft Outlook, it has like mail and calendar and contacts. Imagine pulling mail out into module 1, and you'll have another module for contacts and another module for your calendar. But what that does is when you pull each one of those major functional areas of your application out into a separate project, a separate assembly, and then at runtime, you start to inject those views. You inject that code into your shell project. Okay, so that's how we are composing these views. Okay, we compose the application at runtime. Although the application is built in different projects, spread across different projects, and the main project is really just an empty master page, at runtime, it will be smart enough to know, I need to show this UI in the main shell. I need to show that UI in the main shell. So we want to write our applications in a way that they are more composable at runtime like this. So how do we do this? How do we solve all those challenges of writing these applications and build apps in this modular way? Well, we're going to use a framework, and this framework is called Prism. Well, technically, it's the Prism library, but for short, it's called Prism. And Prism is essentially a XAML application framework, okay? It uses developer design patterns and practices to help guide you down a path to success of building these loosely coupled, maintainable, extensible, and testable applications out of the box. Right? This is what Prism is all about, being testable, maintainable, and easy to write. It's all about guidance, guiding you down a path to success. And the great thing about it is it's open source. It's freely available. This is not something you have to buy It's on GitHub. It's part of the .NET Foundation, and all it does is it's a set of guidance that you add to your project to help guide you down this path to write more loosely coupled, maintainable, testable applications. And these are composite applications, right? We write them in a modular way, and then they're composed at runtime. And so when you ask yourself, well, what does Prism really give me? Well, Prism's going to give you obviously MVVM support, not required, but it relies on it. I mean, I don't want to say it relies on it. It can use it heavily. And if you're writing a WPF, Xamarin Forms, and Uno XAML application, you're using MVVM. Okay. It comes with commanding, messaging, right? How do we communicate between these loosely coupled components? How do I communicate from this view to that view with having no reference to each other? Navigation, getting from one view to another view, dialogue services. How do I show dialogues? How do I, invoke some type of dialogue to my user and respond to that interaction from the user? Modularity. This is breaking the application up into smaller pieces, just like we were talking about. And then at runtime, having those pieces come together. And then boom, we have this awesome, maintainable, extensible app that we can just keep extending the life. And it's just a beautiful thing. I love these applications. And most importantly, Prism it depends on dependency injection. And if you're not familiar with dependency injection, it's a really simple concept that we'll talk about a little bit during my demos. But essentially, all it is you are no longer creating types in your code. Instead, you're going to rely on this container to provide these types for you. Okay, and you'll see some of this in action when I start getting into the demos here. And actually, we're gonna get into the demo right now. Actually, it's demo time. So we're gonna come out of our slide deck here, and the rest of this is going to be all code. Now, to make this demo go a little faster, I'm going to be using what's called the Prism template pack. So if you go to Manage Extensions inside of Visual Studio, and you go ahead and search for the Prism template pack, okay, you're going to want to install this because it's going to provide you with a number of item templates, project templates, and code snippets to help development go a little faster. Okay, so what I'm going to do is I'm going to start by creating a new project. We will make a WPF .NET Core application. How about that? You want to do .NET Core? It's all the rage nowadays. And I'll just call this my Prism app. And we're going to choose our container. Remember, I talked about dependency injection briefly. So to achieve dependency injection in Prism, we're going to choose a container. Now, by default, Prism ships out of the box with dry IOC and Unity. We're going to pick dry IOC. And then now what's going to happen is Visual Studio is going to create a very simple Prism application for us. Now, when you first look at this, it's going to look like a normal WPF app, and it really is. The only main difference is that instead of being a instead of being a WPF application, if I open up my app.xaml, you'll see this is a Prism application. This is no longer a WPF base class application base class. This is a Prism application. So when we come into our app.xaml.cs, we already notice it's slightly different, right? We have two methods that we really care about right now. One is called create shell, and the other is called register types. So what create shell does, this method returns the main window of the application, okay? So if we look at our views folder, we'll see that we have a main window defined. If we look at this main window, we're going to see it's of type window. We're binding to a title. We'll look at this in a minute. It's coming from a view model. And then we have a content control acting as a region. Now, we'll talk about this in a minute. But what I really want to show here is that we have a window class. It has a view model associated with it. If we look at our code behind, we'll see there's no code behind here. Okay, and then we have a view model, main window view model. We look at this class derives from a bindable base. This bindable base is a class provided by Prism, and all it really does is provide an iNotify property change implementation. So your property snippets can look like this, where we have set property, and this will automatically call the iNotify property change, which is required for data binding inside of a XAML application. Now, what you don't see here anywhere, even if in my app.xaml, is where I set the data context of this view model, all right? Of the view to the view model. So I'm going to run the application really quick. And then we're going to see that the title of the window, so here's the application, here's the main window that we just launched, and you can see the title is bound, Prism Application. If we look at our main window view model, that's where that title is coming from right there. So you're going to say, well, Brian, how is that being set? Well, Prism uses what's called a view model locator. However, Prism's implementation of view model locator is special because it doesn't require you to create any type of static classes or any crazy stuff like that. Essentially, all you have to do is set the viewModelLocator.AutoWireViewModel property to true. That's it. And then it uses a convention that says, hey, I know the name of the view. I'm going to append viewModel to it. And I'm going to find a class called MainWindowViewModel. I'm going to create an instance of that class. And then I'm going to inject it into the data context of your view for you automatically. So it happens for you automatically. Okay. Now, one of the first things I want to cover right now is the whole modularity aspect, right? So I talked about our shell application where the shell with the main application is just a shell. It's a master detail page. You don't know what's going to happen, very loosely coupled. And so what I'm going to do is I'm going to leave this main application alone, okay? I'm going to add a new project to our solution here. This new project, do I have it? No, let's go ahead and search for Prism. Do I have a module template? Yep. So I have a Prism module for .NET Core. So I'm going to create a new project here. I'm going to call this Module A. Going to go ahead and create that module. So now we have a module, okay? And a module is nothing more than a major functional area of your application. So I talked about Outlook, where it has the calendar, the contacts, mail. Well, imagine pulling each one of those major areas out into its separate module, right? So calendar would be its own module. Contacts would be its own module, okay? So now we're creating a new module. This is simply, it's just a class library that has a class in it that implements iModule. So in order to let Prism know about this module, we're just going to add a reference to it. There's multiple ways to do this. You don't have to add a hard reference. You can keep this completely loosely coupled. These modules can be loaded from, obviously, code. It can be loaded from a directory. You can do it with an app.config. Just know that a hard dependency is not required for this to work. So now that we have a module, I want to override configure module catalog. And what we're going to do is going to say module catalog. We're going to add a module. And what's that module? A module. We're going to go ahead and add our using statement here. And we have added a module. That's all we did. We just added a module. And what I'm going to do is I'm going to hit a breakpoint on this on initialized. And I'm going to run the application again. And all I'm going to show you is that we are loading this module. Boom, right there. We hit the breakpoint. The module is loading. So what does that mean? That means that Prism has discovered this module, and now we're going to invoke code that this iModule interface will provide to Prism. Okay, and what this does is it gives us an extension point. So for example, this module has a view in it called View A. Let's look at this View A. And we have a message, so it has a view model. It's bound to the view model using the view model locator. Here's our view model. And here's our message, View A from your Prism module. Okay, great. So now what I want to do is I want to inject this view into our main application. So in order to do that, let's kind of back up and let's talk about regions. Now, a region, the concept of region is very simple. Essentially, it is a placeholder for dynamic content, okay? This is a placeholder for the views you will inject into your application or throughout your application. So right now, I have defined a region by using Prism, region manager.region name equals content region. That's all I had to do. Now, anywhere in my application, in any module, I can add a view to this region by name. Now, keep in mind, this view, this module A has no reference to the Prism app. It does not know anything about this main window whatsoever, okay? But what I'm going to do is, let's close this for now. I'm going to let this module inject a view into that main shell, okay? And so there's a couple of ways to do this. One way to do this is to use what's called view discovery. View discovery will automatically inject a view when the region is ready, okay? And to do that, we're going to say container registry. Oh, excuse me. Don't want to do that. We need the region manager. So I'm going to create a constructor. And in this constructor, I want to inject the I region manager. Let me add a field because I may want to use this later. Okay, so for example, I may say region manager dot register view with region. We're going to need the region name, which we called content region, and then the type, which is type of, we'll call this view A, right? Isn't that the type? So I'm going to discuss what's going on here in a minute, but I'm going to run this application as it is, and let's see what happened. Okay, boom, look at that. We have injected the view A, into the content region of the main application, even though this module does not know or have a reference to this assembly, this project, this executable. It has no idea it exists. It just knows that it needs to look for something called the content region, and then I'm going to throw this view into it. Okay. Now you're going to be saying, well, Brian, how did you get this region manager? Remember what I talked about dependency injection. Okay, so Prism relies on dependency injection. And what this means is that you are not going to be creating your type. So for example, let's say I have something called a person service equals new person service, right? In your code that you write today, you probably do something like this. In my code, I don't do that, okay? Nope, not for me. Instead, you will inject your services through your constructor. Okay, and to do this, all you have to do is let the container know about it. Dependency injection container. We are placing the responsibility of creating these objects onto something else. And all a container does is says, oh, I know what an I region manager is. Since I know what it is, I'm going to provide it for you. And if that region manager has any dependencies of its own, I will create those too, right? So essentially, it is just an object. A dependency injection container is just an object that creates objects for you, okay? That's all it really is. And you have to register your services with the container so it knows about it. And Prism has a lot of these services registered by default. That's why I can just go ahead and when I run this, we're not newing up any region manager. We're just getting it, right? So we have an instance of a region manager here. But I didn't have to new it up because the container knows about it, okay? Because Prism handles that for you. Okay, now another thing we can do here is we can do what's called view injection. So what I just did there was called view discovery. A view injection is different. View injection says you're going to be responsible for creating the view, right? And then you're going to add the view when it's ready. So for example, I might do something like this. I might say, region manager dot regions index of content region dot add new view A. So I'm going to run the application. It's going to work the same. Let me drag it over here. It works the exact same, but the difference here is I'm creating it. Now you would never do this. Like I'm never do like new. Okay, you shouldn't do new. No new. Don't do new. Instead, you might do something like, var view equals container provider dot resolve view A. And then we will add the view. So you're going to say, well, Brian, I still don't really understand what's going on here. What's the difference? Okay, so it still works the exact same. Well, here's the difference. I'm going to comment this out. Let's put new view A in here. Okay, I'm going to put new view A in there. And let's say I need something in my constructor. I want the I region manager in here. Right? I just need something, some service, whatever it is. This is just an example. Now, when you come here, we've broken our app. Our app is broken. Everywhere in our application where we have said we want a new view A, we have broken. Now we have to come in here and we have to add code to fix it. However, if we don't do that, I don't have to change any code, but check this out. I'm gonna hit my breakpoint back here. Because we're using our dependency injection container, I can add whatever I need, and the container is going to give me that instance, right? So it gave me the region manager. Okay, what if I want something else? Well, if I have time, I'll talk about the I Event Aggregator. Let me add our using statement there. Whoops. Right, okay, I just added a new parameter to our constructor. Well, look, in our module, we didn't break anything because we're not newing it up. It's not broken. Let's run the application. And there, we have an instance of the event aggregator because the dependency injection container is creating that for us. Okay, so we don't have to worry about that. So when you write Prism apps, avoid new. Okay, just avoid new. Now, for simplicity reasons, just for simplicity, I want to keep view discovery. Remember, view discovery it's going to be automatic. We're going to inject a view A whenever the content region is ready. So this is automatic, okay, for now. And I want to show some of the benefits of using some of the Prism types, okay? So for example, let's go into our view model. And what should we do here, actually? I want to think. Let's go into our view, and I'm going to change this to a stack panel just because it's going to make it easier. And let's add a button. Let's add a button. We'll just say click me. And what's this button going to do? This button, let's bind a command. Let's create a command. We're going to do some data binding to, let's say, what do we want to do here? I'm thinking, do we want to do this? You know what? Let's do something different. Let me undo that. Undo all that. Let's keep that a grid. Actually, let's talk about navigation because I think that's really important. And at the same time, we can talk about some of the commanding features that you get. Okay, so let's create a new view. I'm going to add a new item. I'm going to go to Prism, WPF. I'm going to add a new user control, and I'm going to add a new view. I'll call it View B. Okay, I got my View B. I got my View B view model automatically created for me, which is awesome, right? Let's go ahead. You know what? I don't need a view model for that one. Do I want to do that? Yeah, let's do this. Okay, I'm just going to copy. I'm going to copy and paste that into here. And let's set the message equal to View B. Okay. And then do we have anything in our View B? No, we don't. So let's open up our View A. And I'm just going to copy and paste this. Right, I just want a message in here, nothing fancy. Okay, perfect. We're binding to our message. That looks good. Okay, so let's talk about navigation first. Because injecting views manually by creating them or by using view discovery like this isn't actually what we want to do. Okay? You would only use view discovery for items that need to appear immediately. We're talking things like menu items, right? Status bars. Things that are going to show up in your app when it first launches. That's when you would use register view with region. However, let's talk about, getting from one view to another. Now that would be interesting. So for example, let's go into our main window and I'm going to do something interesting. Should we let's keep this a grid. Actually, let's keep this a grid. Let's add some row definitions. Row definition, height, auto. Okay, and we'll do this star here. This will be, what do we want this? Grid.row 1. And then I'm going to add a stack panel. Let's set the orientation equal to horizontal. And now let's add some buttons. Yeah, okay. I like this better. Let's do this. Navigate to view A. Copy this button, navigate to view B. And what I want to do is I want to navigate these views even though they exist in another project, right? So let's create a command. We'll do a binding. We'll call it, navigate command. Would that work for you? Works for me. We'll set the command parameter equal to view A. And I'm going to copy this. And I'm going to paste it in here, and we'll change that command parameter to view B. So what I want to do is when I click the view A button, I want to navigate view A into the content region. When I click the view B button, I want to navigate into view B, or excuse me, view B into the content region. So let's go into our view model for the main window, and let's add a property. Right? Let's add, I'm going to add a property. I'm using a code snippet from the Prism template pack. And this is going to be called navigate command. Tab that out. Navigate command. We need to add our using statement there. And now on the execute command, we want to navigate our views. So in order to perform navigation in Prism, there is a step we have to take first, okay? And this step is we have to register the views for navigation. So what I'm going to do is in my module under register types, I'm going to say container registry dot register for navigation view A, and I'm going to provide the view A view model. I don't have to do this, but I'm going to. Okay. And then I'm going to do the same thing for view B. Now, remember I was talking about view injection and the container has to know about your objects. Well, this is letting Prism know about your view. And when I provide the view model, I'm actually bypassing the naming convention for the view model locator. So the view model locator, by using this attribute, this attached property where it uses a convention, well, that uses reflection. And I want to avoid that reflection. And I'm just going to say, hey, use this view model instead. So now that I have registered my views for navigation, I can now use the region navigation service to navigate my views. So let's go back to our main window view model. And let's implement this command, this navigate command. First, we need the I region manager inside of our view model. Now, once again, we are using dependency injection. So all I have to do is ask for it. Okay. Now that I have it, let's say region manager request navigate, and I want to navigate to say the region name. In this case, is content region, and then the source. Right. In this case, it's the parameter which we're going to call. What do we want to call this? I'm going to call it view name. How about that? Let's rename that to view name. Okay, pretty easy, right? So we're going to look at this, and when I navigate to the content region, we're going to pass in the view name. The view name is going to be view A. We know that because when we register the view for navigation, by default, it's going to take the name of the view as the key. Right, so in Prism, you are navigating based on URIs. We're using a URI to navigate around. And so this is going to let us navigate from view to view without each project knowing about each other. So I will be able to navigate from the main app without ever referencing the view type or another module. Like we are completely unlimited on how we want to navigate based on views that exist in other modules. So navigate to view A, there it is. Navigate to view B. Beautiful. Check that out. Back and forth, back and forth. Okay. Now, what's really cool about this is besides, being able to navigate from view to view without even knowing about the view, it's just based on that registration key. So if I had a module B, I could navigate in module A to a view that exists in module B without module A ever having to reference module B. Let that just sink in for a minute because that's amazing. Now, another thing we get to do here is when we navigate, we can pass parameters back and forth. So these view models can participate in navigation. And so, for example, I want to say, I navigation aware. I'm going to implement I navigation aware. And what this does is it lets these view models participate in the navigation process that Prism provides. For now, I'm going to return true here. Now, so I know when I'm navigating to, and I know when I'm navigating away from. So let's go ahead and click onto these. I'm going to go ahead and run the application again. And so when I navigate to view A, we're going to hit the view A on navigated to. And then when I navigate to view B, we're going to hit the on navigated from view A as we go to B. Okay. Now, what's cool about this is we can pass parameters while we navigate. And we have a couple of ways to do this. But I'm going to go ahead and say var p for parameters equals new navigation parameters. This allows me to add parameters. So for example, I'm going to add ID and the value will be like 23. Okay. Now I can pass these parameters along just by passing the navigation parameters in my request navigate call. And the way I get these is in the on navigated to of the target view. I can say, how about message plus equals navigation context dot parameters get value. It's a type int, and the key was what, ID. Let's go ahead and run this and let's see what happens. So I'm going to run the application. Application is going to launch. Here's the application. Navigate to view B. In there, I passed. Navigate to view A. I passed that parameter to the navigation, and I appended the 23 to the end of the message. And so there we have view A for module 23. Now, there are a ton of great features in Prism, and I don't have a lot of time to talk about a lot of them. But another common problem that you'll run into is, how do I communicate from, one view to another? Like, say, for example, something happens in view A, and I want that message to be sent to view B, okay? Well, in order to do that, we're going to use what's called the I Event Aggregator. Now, let's start by creating a new folder. I'm gonna call this Events. And actually, do we want to do that? Or, yeah, let's do this. Okay, so I'm gonna add a new class. And I'm going to call this, I don't know, just message event, whatever it is. And this is going to be a pub sub event of string. And you're going to say, Brian, what the heck are you talking about? So Prism's event aggregator is a publish, subscribe eventing system inside of Prism. Okay. It allows you to communicate between loosely coupled components using events. And these events contain what's called a payload. This type of T describes that payload type. In this case, it's a string. You may have a person, you may have a message object, whatever it is, okay? So in order for the event aggregator to work, you have to have a publisher and a subscriber. So we need a publisher. You know what? Let's go ahead. Let's go to our main window view model here, and we'll make the main window view model the publisher. So in order to do this, we need to ask for the I Event Aggregator. And I'm going to save that off. I'm going to add our using statement. We're going to create a field. And when we request our navigation here, I want to send a message. Okay. For example, or maybe, well, yeah, we could do it here. That's fine. Let's go event aggregator .get event of T. This is going to be message event. Oh, and actually, yeah, we can do this. We could do this. Okay, message event. And we're going to publish this event with a payload of type string because we said that payload was going to string. I'm going to say message. Oh, how about navigated to, and we'll put the view name. How about that? Will that work? I think that'll work. And we'll say view name. Okay, so now that we have a publisher, we need a subscriber. So in this case, let's go to our view B view model in a different project, right? And we will ask for the I Event Aggregator. We'll add the using statement. And here I'm going to subscribe to this event. So I'm going to say get event, the event I'm listening for, which is the message event. and then we're going to subscribe. And our subscription is going to be message received, right? And then let's generate that message. I'm going to call this payload. So what's going to happen is when that message is invoked, we're going to receive that message. Now, for now, let's go ahead and set the message equal to payload. So I'm gonna run this app, and let's see if I mess anything up. I'm normally pretty good at that. So I'm gonna navigate to view B, and we could say navigated to view B. Now, view A isn't listening for that event, so its message doesn't change. But I am sending a message from the main executable, right, to the module A view B view model, and it's receiving that. And I can have multiple publishers, and I can have multiple subscribers. Now, I have just a few minutes left, but I want to talk about some options that we have off of the command object that we created in our main window view model. So let's open up our main window here, and right in here, I'm going to add a checkbox, and I'm going to set its text to like can navigate. Okay. And let's say is checked binding to is checked. Sure. So this means we have to do a couple things. First, we need to add another property. And I'm just going to do another snippet called prop P to be a type Boolean. And this is going to be called is checked and is checked. Okay, so by default, it's going to be false. And so what we did here is with our navigate command, we need to add a can navigate. What do we call this? How about this? Can execute command. That's what I'm going to call it. So the can execute command, what this does is it essentially tells the command if it's allowed to invoke, right? So we're going to return the is checked. All right, so let's run the application. And what we should expect is that these should be disabled, which they are because can execute is false. But when I check this, they should be re-enabled because it's true now. But how do we do that? What's going on here? What's the problem? I'm going to minimize this so you can see that. The problem is we have to let the command know that the state of the checkbox has changed. So one way to do that is we could do something like, we can say, what's the name of this command? Navigate command dot raise can execute changed, right? So we can manually make that call when the property is set. We can go ahead and requery the state of those buttons. So, okay, cool. Now I can navigate. My message is being sent. If I uncheck that, now I can't click the button because I'm not allowed to execute that command. Well, I don't like having dirty setters. And what that means is I don't like having code in my setters, okay? So instead, what we can do, I wonder if I want to bring this down so you can see it, is I want to provide or show you a feature that the delegate command has that is pretty amazing. It's called observes property, okay? And what this does is it will observe properties in your view model for value changes. And when that value changes, it will automatically call the raise can execute changed to requery the can execute method, right? What's the result of this is checked. So if I run this application now, we're going to see that we have the can execute. These are disabled. But now I'm going to click the button and it automatically just worked, right? It said, oh, the value of this checked changed and it's true. So now I can navigate. If I uncheck that, same thing. And you can observe as many properties as you want. It doesn't matter. Now, another cool thing, one last thing, I'm running out of time. I'm sorry. One last thing I want to point out about this is, let's say in this case, the is checked property is a Boolean and it represents the can execute. So why should I even have to provide a can execute delegate in my delegate command? Let's just delete this altogether. Like, I don't need that. Instead, the Prism delegate command allows you to call, observes can execute. So what this does is not only will it check the property that you've provided for value changes and call the raise can execute change, but it will also use the result of that Boolean value as the can execute handler, right, of that delegate. So I'm going to run this application again. We deleted the can execute change of the command, but look, it still works the exact same. Okay. Now, I know I went really fast. I covered a lot of information, and it's like a water hose just being pointed right at you. But hopefully you can see a lot of the benefits that you'll start getting on how easy it is to write these composite applications that are extensible, testable, maintainable, right? All the great things that you want in an application architecture, Prism will provide for you. That's my time. Thank you, everyone, for inviting me to speak at your event. I hope I was able to provide some value to you, and I hope to see you next time at another event near you. Thanks.